Today I'd like to introduce you to a new term through a lab we're going to be working on. So the new term is the term resistance, and we want to look at the resistance of a wire. Specifically, we want to learn how the thickness of the wire affects the resistance of the wire. So here's what we're going to do. First of all, you got your quote of the day. And then you got something a little different. I normally don't do this at the beginning of a lab, but this is a concept that you're not as familiar with as some of the others that we've studied. So I'd like you to take a look. You see two people stringing up some telegraph lines back in the 1800s. We were just starting to learn how to utilize electricity, and one of the first applications was connecting cities together with a telegraph line. We could send information from city to city in the blink of an eye. The problem is they started to realize that when they made the wires longer and longer, it was harder and harder for the signal to pass through the wire. What we'd like to do today is figure out not the length of the wire, but how does the diameter of the wire, the cross-section of the wire, affect how easy or hard it is for the electricity to move through the wire. So back in the day, they had a lot of different units that they used to measure how tough it was for a signal to go through the wire. Everybody used different standards to do this, and the world was a chaotic mess. Well, the world is still a chaotic mess, but at least in this one area, we eventually all agreed on one unit to use for the resistance of a wire. It's a beautiful unit. So this unit is called the ohm. It's named after George Simon Ohm. And this is how they defined the resistance with this unit ohm. So they took their wire, they measured how much current was going through it, and then they changed how much voltage they were applying to the wire. And they adjusted the voltage until exactly 1 amp of current flowed through the wire. Whatever voltage that was, let's say it was 9 volts that was needed to get 1 amp to go through the wire, that number is the resistance of the wire in ohms. So for instance, if it takes 9 volts, that means it's a 9 ohm resistance wire. If it had taken 100 volts to get 1 amp, then we would have had 100 ohms. That would have been a tougher wire. So the more volts that were required, the tougher it was to get electricity through the wire. This standard is now the standard that is used all over the world. It's one of the few things we all agree upon. It is a beautiful unit. Again, the ohm is the voltage required to create a current of exactly 1 amp. So what you're going to do is you're going to open up a program, you're going to have a variable voltage power supply, and you're going to have a current meter. Your job is to get the current meter to read 1 amp. When you're at 1 amp, whatever the voltage is, that will be your resistance. So for instance, in this case, you can see we're at 1 amp, so the resistance would be 0.76 ohms. You're then going to change the wire. This is the cross section of the wire, so that is we cut a slice and we look at it end on. It's a circle. It's going to calculate for you the area. It's going to show you the radius of the wire. Each of these little blocks is 0.1. So this one is about 0.88 millimeters. And again, this is the area. So you just click and change the thickness of the wire over and over and over again, maybe 8 times, 6 or 8 times, whatever number of spaces I put on your lab sheet, and you'll get a nice sampling of data. Again, for each one of these, you adjust this until the needle is pointing to exactly 1 amp. How do you adjust it? You grab it with your mouse and you slide it right or left. If you need a higher voltage than what it's giving you, just switch it up to the high voltage. Don't do that unless you need to. So if you need more than 3 volts, click it up to high and be on your way. All right, so again, this is your radius, this is your area. You don't have to calculate them. I wanted this to go really quick. Okay, so again, move your voltage slider till your current reaches 1 amp. Repeat for a range of different thicknesses. And then plot it out. You want area in meters squared, and you want resistance in ohms. When you're done, curve fit it, get your equation, and then see if you can predict some stuff. Again, if you get this wrong, not a big deal. It's always for extra credit. Okay, so show me your certificate, whether it's right or wrong. Make sure you give your equation. Again, don't use X and Y. And finally, the stuff you want to have in your conclusion. I think you should be fine with the first 3. Number 4, what factors could have affected your resistance besides the thickness? Well, we already talked about with the telegraph. Okay? We talked about how they went from city to city. It became harder and harder based on the distance between the cities. Source of error and how you could have fixed it. And are there any limits that you can think of to your model? If you can't think of one, just give it your best shot. I'm not going to penalize you, but I would like to see what you're thinking. Anyway, best of luck. If you run into any troubles, you can come see me during McCully 1.